During this lesson, we will be looking at the different modes of operation of a flight director system. We will achieve this by following a typical flight from departure through climb, cruise, descent and approach until the aeroplane lands or goes around. Flight director modes generally are type-specific, and so we will concentrate on the most common ones in use today. The glide slope and course deviation indicators on the side and bottom of the attitude direction indicator display basic raw information, which is still available if the flight director system fails. This is information that has not been processed in any way, and in this example it simply shows how far left or right of track and how far above or below the glide slope the aeroplane is. If we look at an aeroplane that is intercepting a desired navigational track using only raw data, we will see that the aeroplane fails to anticipate approaching the track. So the aeroplane flies through the track and then has to continue the turn to intercept the desired track from the opposite side. A flight director computer takes this same raw information but processes it, working out the rate of change of deviation. This additional data allows the system to anticipate approaching the required horizontal or vertical flight path, and therefore it can adjust the amount of roll or pitch input so that the aeroplane smoothly intercepts the flight path and does not fly through it. The flight director adjusts the flight director bars, which can then either be followed by the pilot or, if engaged, the autopilot. The flight director system has the aircraft performance parameters stored in its database, and with the input from the air data computer, it will never command a maneuver which could overstress the aircraft. Before we look at the departure, let us look at the instruments we will be using to set and display the flight director information. Firstly, to set the information onto the flight director system, we have the mode control panel and the flight management system. The flight management system affects lateral navigation, LNAV, and vertical navigation, VNAV. These are selectable pre-programmed routes and vertical paths for the flight director system to follow, although for the majority of this lesson we will be concentrating on the mode control panel inputs. To display the flight director information, we have the primary flight display and the navigation display. The only other piece of equipment we will look at briefly is the VOR navigation selectors, as they tune the required frequencies that the flight directors will follow when VOR lock is selected on the mode control panel and a course is set on the course selector knob. As part of the pre-departure planning, the crew will complete the necessary calculations to work out departure speeds and initial climb angle. The V2 speed will be set on the mode control panel. They will also find out the departure procedure, which will include maintaining runway heading, which in this instance is 010. As well as that, there will be a track to follow, which in our case is the 161 degree radial out of Oxford for the Botley interchange, and then the 180 degree radial to Compton. To achieve this, the crew requires Oxford's and Compton's frequencies to input into the navigation equipment. Next, we need to set these frequencies and the courses to follow on the mode control panel, along with the VOR lock selector. Finally, the crew will be given an altitude or flight level to climb to, and this will be set on the mode control panel and shown in magenta on the flight mode annunciator. During departure, with the flight directors selected on, the crew have two methods of displaying a pitch demand on the primary flight display. Firstly, they can bias the pitch demand manually to a pre-calculated setting, which is displayed on the primary flight display. This gives the pilot an initial body angle to aim for after rotation. The other way is by selecting Takeoff Go-Around on switches on the throttles. This positions the pitch bar to command the initial body angle on rotation, and we are informed of this on the flight mode annunciators. After rotation, the flight director will alter the pitch command to maintain the best climb angle, until the indicated airspeed reaches the mode control panel speed, plus 20 knots, and the crew will also select Heading Select to command the roll bar to maintain the selected heading. The pitch command will remain this way until another pitch mode is selected, and we will use vertical speed. This selects the vertical speed we wish the aeroplane to climb at. In this case, 1500 feet per minute has been selected, which the flight director then commands. As the aeroplane reaches the mode control panel selected altitude, it will command a level altitude, and once level, the crew would then select altitude hold to maintain the desired altitude. Next, the pilot will be given a heading to intercept the course for Botley from air traffic control, which he will select on the mode control panel. The flight director will then command a roll angle to turn the aeroplane to this heading, which is known as Heading Select, and the pilot will then also select Vorlock in anticipation of intercepting the selected course. As the aeroplane approaches the selected course, the flight director will automatically command a left turn to intercept this course, which is known as Vorlock control. The other way to set up lateral navigation is by using LNAV, which utilises the Airways Track database in the flight management system. The flight director computer, using a combination of inertial navigation and global positioning systems, and the selected track from the flight management system, sends commands to the primary flight display, so the pilot can follow the selected track. This system can be used all the way, from pre-departure until arrival at the destination. LNAV mode is displayed on the flight mode annunciator in green, with the actual track being displayed as a magenta line on the navigation display. During the climb, cruise and descent phases of flight, most mode changes will be in pitch. From departure, we were in takeoff go-around, vertical speed, and then altitude hold. For the next stage, we will be climbing to the final assigned altitude using level change. The flight director commands a pitch attitude to maintain the MCP selected speed, and the pilot selects a constant thrust. As the aeroplane approaches the desired height, the flight director commands a level off attitude, and if the pilot did nothing else but level off, the aeroplane would then accelerate, so he also has to decrease the power available. He would also select altitude hold again to accurately maintain the desired altitude. The other means of controlling the vertical profile is by using a mode called VNAV, which has various pre-programmed climb and descent profile databases stored in the flight management system. As the descent phase is commenced, the pilot will select the cleared flight level or altitude on the mode control panel and select level change. The flight director will then command a descent on the pitch bar. The pilot will reduce power to maintain the selected speed, and as the aeroplane approaches the selected altitude, the flight director will command a level off attitude. The pilot will again have to increase power to maintain the desired indicated airspeed, and select altitude hold to maintain the desired height more accurately. As the aeroplane reaches its destination airfield, the pilot is normally given radar vectors to intercept the Instrument Landing System or ILS approach. To follow radar vectors, the crew will select Heading Select mode on the mode control panel, deselecting LNAV and putting the flight director back into Heading Select mode. As with the departure, the pilot will check the ILS plate for Southampton to obtain the course, and the ILS frequency will be set on NAV1. The course will be set on the mode control panel along with Vorlock. The flight director will automatically command the pilot to intercept and track the localizer. Once on the localizer, the pilot will select Approach, which arms the glide slope. On intercepting the glide slope, the flight director automatically switches from altitude holding to glide slope. The pilot will then follow the flight director pitch and roll commands until he reaches decision altitude, and then visually continue to land. If we look at a typical glide slope path of 3 degrees, it can be seen that a 1 degree deflection at 6 nautical miles would give a distance above or below the glide slope of 608 feet. So the flight director can demand the maximum pitch change to try and get the aeroplane back on the glide slope. At half a nautical mile, the same 1 degree difference now only creates a height difference of 54 feet, and the demand from the flight director has to be reduced to between 1/3 and 1/2 of the previous full demand. So the flight director computed information must be modified as the approach progresses to reduce the commanded corrections. Most modern systems achieve this by knowing their actual height above ground from the radar altimeter, and restricting the demand as they get closer to the ground. Let us look at the go-around aspect, as land will be covered during the Autoland lesson. As the aeroplane approaches the runway, it will be under the direct control of the operating pilot, and if there is a need to overshoot, then takeoff go-around would be selected. On selecting takeoff go-around, the flight director pitch bar demands 10 degrees pitch up, and the engines are accelerated to take off go-around thrust. Once the aeroplane is at a safe altitude, the crew will then talk to air traffic control for radar vectors for another approach. The vital information to take away from today's lesson is that the flight director takes the raw information and provides either the pilots or the autopilot with computed information. This is derived from the rate of change of deviation and displayed as command bars on the primary flight display. During an approach, the flight director computed information must be modified as the approach progresses to reduce the commanded correction.